Welcome to the DIY Honda Garage channel. The DTC Diagnostic Trouble Code P0103 refers to a high voltage condition in the mass airflow MAF sensor circuit. The MAF sensor is a key component in the vehicle's fuel management system, as it measures the amount of air entering the engine, allowing the Engine Control Module, ECM, or Powertrain Control Module, PCM, to adjust fuel delivery accordingly. A high voltage condition indicates that the sensor is sending a signal greater than the expected threshold to the PCM, which can lead to engine performance issues, poor fuel economy, and increased emissions. This trouble code is observed in Honda CRV models manufactured between 2017 and 2022. Proper diagnosis and troubleshooting are vital to rectify this issue and restore optimal engine performance. The MAF sensor plays a critical role in the vehicle's air intake system by measuring the volume of air entering the engine. It is typically situated in the intake path, often located near the air filter box. The MAF sensor provides electrical signals to the PCM based on the airflow, which allows the system to optimize the air-fuel mixture for efficient combustion. A fault in this signal, particularly a high voltage reading, triggers the DTC P0103. High voltage is generally defined as a reading above 4.89 volts, indicating a malfunction or error within the sensor circuit, which can compromise engine performance and efficiency. Additionally, the integrity of connections to both the MAF and intake air temperature (IAT) sensors should be inspected, as they are interconnected. Several potential issues could lead to the triggering of DTC P0103. A faulty MAF sensor itself is a primary cause, where the sensor may become unresponsive or send erroneous signals to the PCM. Another significant element is an open socket in the wiring, which can disrupt communication between the sensor and the PCM, causing the voltage to spike above the normal threshold. Additionally, a malfunction within the PCM could also contribute to false readings. Intermittent connections or poorly secured terminals can exacerbate the situation, leading to temporary faults. Diagnosing these issues efficiently requires careful examination of both the sensor and its associated wiring, as well as conducting continuity tests. When DTC P0103 is present, drivers may notice several symptoms indicating an underlying issue. One prominent symptom is reduced engine performance, as incorrect air-fuel mixtures can hinder acceleration and overall driving experience. Additionally, the vehicle's check engine light will likely illuminate, warning the driver that the engine management system has detected a malfunction. Another common issue associated with this DTC is poor fuel economy, as the engine may struggle to maintain efficient combustion due to faulty readings from the MAF sensor. These symptoms not only affect the vehicle's performance, but can also lead to increased emissions, highlighting the need for immediate diagnostic action. In the first step of troubleshooting DTC P0103, begin by placing the vehicle in the on mode for about 2 seconds. This enables the ability to access the diagnostic data using the Honda Diagnostic System HDS tool. Subsequently, check the output of the MAF sensor to see if the voltage reading exceeds 4.89 volts. This threshold indicates the cutoff point for normal operation. Readings above this could signify an issue with either the sensor or the circuit. If the current conditions match the threshold, the failure is replicated, indicating a definitive fault. If not, consider that the system may be functioning temporarily and inspect the connections for any loose terminals. It is prudent to refer to any recorded snapshots of the DTC to understand conditions during its activation. For the second troubleshooting step, Begin by turning the vehicle to the off position to ensure safety while performing tests. Use the HDS tool to jump the SCS service check signal line and wait for over a minute to allow any temporary faults to dissipate. Following this, disconnect the MAF sensor, IAT sensor 5P connector, as well as the PCM connector B51P to isolate the circuit. Check for continuity between the specified test points, which involves examining the MAF sensor 5P connector's female terminal number 4 and the PCM connector B's terminal number 33. If continuity exists, it indicates that the VGM line is intact, allowing you to proceed to the next troubleshooting step. However, if continuity fails, it points to an open circuit, necessitating repairs to the wiring between these components. During the third troubleshooting step, reattach the PCM connector B51P while ensuring that the vehicle remains in the off position. Disconnect the MAF sensor, IAT sensor 5P connector once more to isolate the MAF signal. You'll need to check continuity between the same test point on the MAF sensor's female terminal, number 4, and the vehicle's body ground. Achieving continuity confirms that the internal circuits of the PCM are functioning properly. If continuity is found, you'll need to replace the MAF sensor or IAT sensor, as they are likely faulty. Conversely, if there is no continuity, it suggests that there may be a fault within the PCM itself, which would warrant checking for authorized service information for this DTC or substituting with a known good PCM as a next step. After performing necessary repairs based on the troubleshooting steps, it is imperative to carry out a final verification to ensure effective resolution of DTC P0103. Start by conducting a test drive of the vehicle under various operating conditions to monitor its performance. During the drive, observe how the engine responds to acceleration and whether the check engine light remains off. Utilize the HDS tool to conduct a final scan for error codes to confirm that DTC P0103 is no longer present. It's critical that the vehicle demonstrates normal operation post-repair, affirming that the fault has been rectified. Only by securing these confirmations can one ensure the reliability of the fix and prepare the vehicle for the driver's day-to-day usage. To help prevent future occurrences of DTC P0103, routine preventive maintenance is vital. Regularly inspecting the MAF sensor for damage or contamination can preempt many issues arising from its malfunction. Ensuring all wiring connections are secure and free from corrosion will improve communication between the MAF sensor and the PCM, reducing the chances of erroneous signals or interruptions in the circuit. Additionally, maintaining the cleanliness of the MAF sensor helps ensure accurate airflow readings, which in turn optimizes the engine's performance. Seasonal checks can capture issues before they escalate into error codes, thereby promoting long-term reliability of the engine management system. Scheduling routine inspections can save time and costs associated with more extensive repairs down the line. In conclusion, DTC P0103 signifies a high-voltage condition in the MAF sensor circuit, essential for maintaining optimal engine performance. Understanding the role of the MAF sensor and its connection to the PCM is crucial for diagnosing and rectifying this error code. Through a systematic approach involving verification, wire checks, and PCM evaluations, thorough diagnostics can lead to effective repairs and restoration of engine functionality. Addressing symptoms early by employing preventive measures can also mitigate the potential for recurrence. Ultimately, diligent diagnosis and timely maintenance ensure that drivers can fully benefit from their Honda CRV's capabilities. ensuring reliability and performance in every journey. Please like and subscribe to the channel. See you next time.